Welcome to another exercise for the workbook statistics. This time about the basics of statistics and in particular on the different scale levels which exist for variables. So let's have a look at the exercise. Here we simply have determined for each of the following characteristics the scale it's measured on. Now we have here the overview of a total of 10 different variables or characteristics. So let's work through those 10 step by step, starting with the height in inches. That's a measure of distances. So I have distances covered already, so it's at least intervally scaled. And I also have an absolute zero. Someone could be 0 inches or something could be 0 inches, but an expression of -2 inches doesn't make sense. In consequence, I can also say, well, it's twice as high as another object, building, person. So that's definitely ratio scaled, not only interval scaled, but ratio scaled. The argument is similar for the second one, for the focal length of an ocular, whereas I would say the most severe one you might get would be something slightly below 10 or 8, usually not going lower. But theoretically, you could argue about a focal length of 0, giving you some kind of absolute zero, of an absolute lower bound. You also can talk about distances. Therefore, this also is a ratio scaled variable. Then we have the date of marriage. Dates always have a problem insofar as I can say, well, it's 2 years since this date, it's only like 8 days until we get to this day. But I do not have like a day 0, and I can say there is nothing beyond day 0. Especially if I'm going to the classical measurements of time. We're going to use usually something like BC, AC, which already illustrates the problem. If I have a before year 0, after year 0, it's no longer an absolute 0 year. So I do not have an absolute 0 with dates, so it cannot be ratio scaled, but I have distances, so it's intervally scaled. That's exactly this. Then, next one, well, I have the date of marriage. I could have the marital status as well. However, the marital status would be something like single, married, divorced, something like this. And I cannot really, well, even order this in a specific way. Well, I could say someone who's married has a higher marital status than someone is single, if I would say marital status is about being married. But what about people who are divorced or people who are widowed? I cannot really compare this, especially not in regard to the other ones. So I cannot even establish some kind of order, but I could still count. There's so many single people, so many married people, so many divorced people. So I do not have an order, so it's not ordinal. But I can still count, so it's nominal. Then I have the unemployment rate. Similarly to before, to the argument in A and B, can say I have an unemployment rate of 0. An unemployment rate of minus something doesn't really make sense, so I have an absolute 0. This usually is already the indicator that I have a ratio scaled variable. But let's work through the other parts as well. Well, I can count how many countries, areas there are with a certain unemployment rate, so it's nominal. I can order them by who has the largest, smallest, and so forth, so it's ordinal. I can describe distances. In this area, the unemployment rate is 0.8 points higher than in that area, so it's also interval. And I have the absolute 0, so it's ratio scaled. Then I have the age of dinosaur bones. The age, as compared to dates, has an absolute 0. If this would actually be, let's say, a newborn dinosaur, the bones would have an age of 0. it's not possible to have like minus ages. Might imagine this. There's no one who's aged like minus 80 years. So age always has an absolute zero, and I can calculate distances. I could say this dinosaur bone is older than that one, and it's older by 2 million years. So it's ordinal, because it's older, I can say it's older or younger, and I have distances, so it's interval, and I have age 0, cannot go below, so it's again ratio scaled. Then I have energy drinks. Here it doesn't really say a lot more, so this implies I'm talking about brands of energy drinks. And I cannot say that, well, energy drink 1 is more energy drink than energy drink 2. I could talk about ingredients, that would be possible, but not about this energy drink is more energy drink than another one. But I could still count how many energy drinks do I consume of brand 1 or of brand 2. So similarly to the marital status, it's nominal. I can count, but I cannot order. Then, with age, I have the read books. If I'm going with the number of read books, I would have a ratio scaled variable. Of course, I can count from 0 upwards. If I'm talking about which books I've read, then it's just nominal. So here it's a question, what am I talking about? The quantity or which books do I have read? So both of them actually work out depending on what I actually read or interpret into the term read books. Then I have vacation days. Similarly to before, it's not possible to get like -2 vacation days. And I can still say, well, I have twice as much or I have 8 more. So everything I need for a ratio scaled variable is given. So that's ratio as well. And finally, this leaves me only with the hardness of rocks. There I have this scale which goes from 0 to 10, which already tells me something about it's limited. But this has the problem, if I have a rock which has a hardness of 10, does not mean it's twice as hard as a rock of 5. Because 10 is the hardest there is, that's like diamonds, and 5, that's something like feldspar, that's something which, well, depending on your strength, you might crumble against some other rocks. So it's not a linear scale. So here you could order this, but even distances might be pretty hard because a 9 and a 10, the distance here is much different than from a 0 to a 1. So with hardness of rocks on the standard scale, this usually is only an ordinal scale. So well, that concludes our exercise on scale levels. I hope you enjoyed it. I hope you enjoyed the examples. And I say goodbye and see you next time.